Hey there, Brian here. Today we're heading above ground to see how the Earth's crust is shaped by forces on the surface. Instead of depositing new layers of rock, as we learn volcanoes do, we'll learn about the surface being stripped away as it is carved into its current form. Our learning goals are to describe the processes of mechanical and chemical weathering, to describe the processes of wind, water, and glacial erosion, and to explain how these processes are connected. Ready, explorers? Welcome to the Grand Canyon, one of the most famous sites in the world, attracting 5 million visitors every year and appearing on many travel lists. If you get a chance to visit, you'll likely agree with John Wesley Powell, who said, "The wonders of the Grand Canyon cannot be adequately represented by speech." So, how did this place, too wondrous to describe, come to be? The Havasupai people, who've been living in the Grand Canyon for more than 800 years, tell this story that explains both the creation of the Grand Canyon and the origin of their people. There were two gods, one of goodness and one of evil. The god of goodness had a daughter who he hoped would be the mother of all living things. The god of evil didn't want that to happen, so he flooded the world. The good god made a boat from a hollowed tree and placed his daughter in it to save her. When the flood finally receded, mountains rose up and rivers appeared, one of which cut through the mountains and created the Grand Canyon. When the land dried, the daughter set foot on a new, empty earth. Then the sun rose up and caused her to conceive. Soon she gave birth to a baby boy. Later, a waterfall caused her to conceive again, and she gave birth to a baby girl. From the union of these two children came all the people on earth. The first of these people were the Havasupai, then the Apache, Hualapai, Hopi, Paiute, and Navajo, all tribes with origins in and around the Grand Canyon. A geologist telling the origin story of the Grand Canyon might say it began 2 billion years ago with the formation of igneous rock, which was formed within the earth from cooled and crystallized magma, metamorphic rock, which has changed from its original state due to high heat and pressure, and sedimentary rock, which is composed of many small rocks formed near the Earth's surface. Then, between 70 and 30 million years ago, the action of plate tectonics uplifted the region and created the Colorado Plateau. Finally, between 5 and 6 million years ago, the Colorado River and its tributaries carved and widened the canyon through the powerful processes of weathering and erosion, revealing the many layers of igneous, metamorphic, and sedimentary rock that we know today as the Grand Canyon. As a geographer, which story is right? The Havasupai tale or the geologist's account? From a geographic point of view, both the Havasupai explanation and the modern geological explanation have value because they both help us understand the truth about this remarkable place. Geographers are interested in the physical characteristics described by the geologist, but equally important is the knowledge of what people in a particular place believe about where they live, the origins of their surroundings, and how it became what it is like today. Furthermore, an astute geographer might notice that both the Havasupai explanation and the modern geological explanation involve the process of water carving the Grand Canyon out of surrounding rock. Both stories point out the actions we know today as weathering and erosion. Weathering is the breakdown of rock, soil, and minerals at the Earth's surface into smaller pieces through contact with water, air, and biological organisms. The process of weathering over millions of years can reduce a mountain to pebbles. Geologists have identified two kinds of weathering: mechanical and chemical. Mechanical weathering is the process by which rock is physically broken down into smaller pieces, producing boulders, stones, pebbles, sand, dust, and so on, ultimately building the soil in a particular area. Frost wedging is a common example. When water seeps into a rock and freezes, it expands, creating a crack. The water eventually melts away, but more water takes its place, freezes in cold temperatures, and widens the crack. Over time, the rock splits apart into smaller pieces. Frost wedging can cause enormous parts of mountains to eventually break and fall away. Other examples of mechanical weathering include tree roots growing in cracks and crevices, rocks cracking due to forest fires and lightning strikes, and cracks from expanding and contracting in times with high and low temperatures. Chemical weathering occurs when a rock's minerals are altered in a chemical reaction. At Mammoth Cave, Kentucky, carbon dioxide from soil and air combine with water to make carbonic acid. The acid dissolved large portions of limestone on the Earth's surface and formed a massive cave system that's over 405 miles long, the largest of its kind. Acid rain is another form of chemical weathering, though it produces very different results. It destroys forests, pollutes water, and eats away the surfaces of stone structures and rock formations. It occurs when chemicals produced by industrial pollution or volcanic activity mix with water vapor in the air and fall back to Earth. Many World Heritage sites, like the Leshan Buddha in China and the Acropolis in Athens, are endangered by acid rain. Erosion, the force that formed the Grand Canyon, works hand in hand with weathering. It occurs when water, wind, or glaciers move weathered materials like gravel, soil, or sand to a new place. This is critical to life on Earth as it builds the soil that plants need to grow. Moving water carries small particles called sediment. Sediment particles impact and grind away at the surface of rocks the water flows over. When a river or stream slows down, the sediment piles up and creates new landforms. A broad floodplain or alluvial plain might form on either side of a river. Or a low-lying plain, known as a delta, might form where a river enters a lake or ocean. The Mississippi River deposits millions of tons of sediment each year along its enormous alluvial plain and in its delta, where it empties into the Gulf of Mexico. Wind is also a powerful agent of erosion, particularly in areas with little water and few plants to anchor the soil. Wind erosion devastated the Great Plains during the Dust Bowl of the 1930s. As the population grew and more land was plowed, huge swaths of land without plant life were left exposed to the wind, which carried away the topsoil in huge dust storms. Thousands of families had no food, no livelihood, and no choice but to migrate west to greener pastures. Glaciers can also cause erosion. During ice ages, when the Earth's temperature is much colder, slow-moving glaciers scrape away at the terrain they move over. Glaciers carved out the Great Lakes in the northern part of the U.S., and when they melted, left behind piles of ridge-like debris called moraines. 50 million years ago, there was a landscape of rolling hills and meandering streams in what is now Central California. After a series of tectonic uplift and the creation of a canyon by erosion from the Merced River, the canyon was gouged and quarried into a U-shaped trough by a series of glaciers. When the last one melted 10,000 years ago, a spectacular sight was revealed. Yosemite Valley, one of the most visited and photographed natural landmarks in the world. What is the most interesting topography near you? How was it formed? Pause the video and respond in your PDF. As we move on in our study of geography, think about the powerful forces on the surface of the earth that carve out the terrain. These are the forces that create the soil in which we grow our food, the canyons and plains where we live, and the spectacular lakes and valleys where we go to enjoy Earth's natural wonders. Look around you. Do you see hills or valleys? Do you see evidence of weathering or erosion? How was the landscape formed where you live? These questions are a few more you can ask to help the world come alive. Stay curious, ask questions, and until next time, keep exploring.
Hey, hey.